Example 3.18. Solve the following quadratic inequalities by the algebraic method. Part A, we would like to find the factors of x squared plus 6x plus 19, but then it's not possible for us to find the factors. So instead, let's consider the quadratic equation. Let's try to find the discriminant. Discriminant is b squared minus 4ac. So we have 6 squared minus 4 times 1 times 19, which is negative 40, and it is less than 0. So the equation has no real roots. Next, let's consider the quadratic inequality. We will be completing the square for the expression on the left. So we are adding 6 over 2 squared and subtracting 6 over 2 squared. So this is called completing the square. The first 3 terms will give us a perfect square of x plus 3 all squared. So finally, after completing the square, the original quadratic inequality becomes x plus 3 all squared plus 10 less than or equal to 0. So let's consider x plus 3 all squared. As what we have seen in the previous example, x plus 3 all squared is a perfect square, so it's always greater than or equal to 0 for all real values of x. And if we are adding 10, then x plus 3 all squared plus 10 must be greater than 0. Will not be equal to 0 because we have added 10, but it should be greater than 0 for all real values of x. So if we go back to the original quadratic inequality, we want to find x squared plus 6x plus 19 less than or equal to 0, which is not possible because as we have seen, x squared plus 6x plus 19 is always greater than 0. Therefore, we have no solution. Similarly, we can do part B. So let's rewrite the quadratic inequality into a quadratic equation. Again, we cannot find the factors of the quadratic expression, so we can look at the discriminant. Same as before, we will be completing the square. So we want to get rid of the negative sign so that it will be easier for us. And when you do so, you have to change the inequality symbol. Next, we are ready to complete the square. We have to take out the coefficient. And we will be adding 4 over 2 squared and minus 4 over 2 squared. The first 3 terms inside the square bracket will give us a perfect square of x minus 2 all squared. We still have 2 in the front, and then we have to take this out. This is negative 2 times 4 over 2 is 2, 2 squared is 4, and we still have plus 17 at the end. So finally, our quadratic inequality becomes 2 times x minus 2 all squared plus 9 greater than 0. And again, we will consider x minus 2 all squared. It is always greater than or equal to 0 for all real values of x. And therefore, 2 times x squared minus 2 all squared will be greater than or equal to 0 for all real values of x. And if we add 9 to it, it's always greater than 0. So this inequality actually comes from original inequality is this one. This is the original inequality. So that's why they are the same. So in that case, negative 2x squared plus 8x minus 17 would be less than 0 for all real values of x. So I have just replaced my inequality here with the original inequality. So it is true for all real values of x. So that's why the solutions will be all real values of x.